All right, here we go. So here's the 4. I already put up the answers for you guys. Stop. 1 works, 3 works, 2 and 4 don't work. Okay? Because 1 tells the story correctly that I have a convergent series and the black one is below it, so it also converges. Do you agree, though, 1 and 2 look so similar? Except it's a plus and a minus. Okay? So just be very careful, because too often students go, hey, 1 over n squared converges, so right away both of these converge. And 1 over n diverges, so both of these have to diverge. You can't say that necessarily. Do you guys see the reasoning? This one I pinched it underneath, so 1 is good. This one I put it above, which is good. On 2 and 4, the red guys, you don't know yet. Okay? You guys okay with that? This one I will tell you up front, 2 does converge, because you agree it looked very similar to the other guy. So if plus 5 converge, the minus 5 should still converge. But you don't know it by direct comparison. And number 3, since both of those are very similar, they actually both diverge, but you can't say number 4 because of the direct comparison test. There's another comparison test out there. Okay? It diverges. These 3 and 4 diverge, 1 and 2 converge. 1 and 3 for sure converge by direct comparison. 2 and 4 do their things by the limit comparison test. Okay? So, limit comparison test says this. You have your 2 guys. They still have to be above 0. Okay? But I don't have to have one guy bigger than the other guy at all. I just need both of them to be positive. Okay? And they always say it, by the way, that the whole time they have to be greater than 0. As long as by the end the tails are going to be greater than 0, you're good. So at some point, if you have all these positive guys, you can use it. And what you do is you put the limit of one guy on top of the other guy. And what you hope for is that limit needs to be finite and positive. As long as the ratio, when you put one guy over the other guy, goes to a finite and positive number, then both dudes either converge or they both diverge. So if the limit of the ratio part goes to a specific number that's positive, then the AN guy and the BN guy, both of them will be convergers together or divergers together. Okay? So the 2 conditions that you need are they just both need to be greater than 0 at some point in life. Okay? And the nice thing is it does not matter who's bigger than who. They can flip around, it doesn't matter. And as long as the ratio of putting them together goes to a finite positive, they both do the same thing together. So this is nice. You don't have to worry about pinching one below another or pinching one above another. It doesn't matter who's bigger or who's smaller as long as they're all positives. And then they kind of do things together with the putting one on top of the other. Okay. I'll give you a second to write. Let's just look at those 2 that didn't work. Number 2 was n equals what? N squared minus 5. Okay. If you do the exact same idea comparing with 1 over n squared, you can look at 1 over n squared versus 1 over n squared. I'll make it colored. N squared minus 5. Okay. And I need to take the limit as they go to infinity. Do you agree here the limit as they go to infinity, I get an n squared minus 5 all over n squared. Do you agree on top? Do you agree on bottom? So that goes to 1. So that means both converge or both diverge by the limit comparison test. They both converge or they both diverge by the limit comparison test. What do we already know about 1 over n squared? Converges by p series. So if he's a converger, what do they both do then? Both converge. Goes okay with that. Is it basically the exact same problem for number 4? Okay, you're going to have the 1 over n and the 1 over n plus 5 or whatever it was. You're going to get it still where the power on top is the same as the power on bottom, so it's both going to go to 1. All I care about is that's finite and positive, so they both converge or they both diverge. And what did 1 over n do? Diverge. So what does the other guy have to do? Diverge. Okay. So sometimes I'll go to here. What's up? Yep. So do you guys see on this one what you would do? You would be comparing 1 over n with 1 over n plus 5. Okay. Can you divide this guy by this guy? What do you get when you divide that basically? 1. So they both converge together or they both diverge together. What does this guy do? Diverge. So what's this guy have to do? Diverge. Which one seems to be a more powerful tool? The direct comparison test or the limit comparison test? Limit. Because there's two things that make it better. Do you care about who's bigger than who? No. And then you don't worry about having the wrong picture. Do you guys see that? In the limit comparison test, you don't even worry about the picture because you just look at one guy on top of the other guy and it's going to work out. Okay? Direct comparison is more specific. It's kind of like Rolle's theorem versus mean value theorem. Mean value theorem is the more broader generic problem, which is like the limit comparison test. What's up? Uh-huh. Yeah, if you do limit comparison, just do the limit comparison. Yep. No, sometimes the direct is pretty quick though. Like, 1 and 3 are pretty quick by just saying this guy's smaller than him and it works, that sort of thing. But you could always avoid it and just say I'm just always going to do limit comparison. Okay, this is why limit comparison is really nice. Okay, is I can give you a lot more complicated of a problem, like this first one up here, and say, okay, I know for sure it looks like the main core part to this problem is 1 over 3n squared. This is the core part to the guy. And do you guys agree that this converges by p series? Okay. So the main essence of that original yellow highlighted problem is really 1 over 3n squared. Do you agree that I have no idea who's bigger or smaller? Because the minus 4n makes the bottom piece a little smaller, but do you agree the plus 5 makes it a little bit bigger? So there's like a minus 4n and a plus 5, and there's a little bit of a, I don't know who's bigger or smaller. So right away, the limit or the direct comparison test, I don't know who's always bigger than who. Because think about this, if you plug in 1, which guy is more powerful, the minus 4 or the plus 5? Plus 5. Plug in 2 though. Who's bigger? The minus 4 times 2 is minus 8. So at some point, one guy might be a little bit bigger, but then later the other guy might be bigger. So direct comparison can't do, but I'm going to do limit comparison. So I'm going to look at the limit as n goes to infinity of 1 over 3n squared minus 4n plus 5 all over 1 over 3n squared. That's the limit. N goes to infinity. That 3n squared pops up top. Degree on top. Bottom. So what's it go to? 3 over 3, which is 1, which is positive and finite. You guys okay with that? So now we know by the direct comparison test, or sorry, by the by limit comparison test both converge or both diverge? But what did we just already learn? That one converges, so what do they both do? Converge. Do you guys see the core to that? How that kind of works out? What's up? Nope. Nope. It doesn't matter who's on top, who's on bottom. Bad. Then I need a new tool. Yep. Then I need a new tool. I don't know, actually. Let me think about that. Okay, take a look at this one. Stop talking. Do you agree the -2 is the annoying part? Do you agree that blue guy diverges by p-series? Okay. Do you agree when you put one guy on top of the other guy, are the powers the same? So do you agree the powers are the same, so it should go to a finite number? It's going to be what I mean by the powers are the same are, here I had like an n squared and an n squared, and when I flipped one on top, the degrees were the same, so it went to a nice number. Is it going to be the same on this one? So they're going to go to a finite number, so both converge or both diverge. Since this guy diverged, the other guy diverges. Look at this one. Think through this one a little bit now with me. What's the core part to the top? To the bottom? Do you agree? The core part on top is n squared. The core part on bottom is 4n to the 5th. So does that simplify to the core being basically 1 over 4n cubed? What's this guy do? By what? P-series. When you divide one by the other guy, it's going to go to a finite number if you did the work. So then they would both converge or both diverge by the limit comparison test. So they both are going to what? Converge. Then I need a new tool. Yep. Okay. Need a new tool. Okay. Here's your homework.